Hi everyone. This short video will provide a brief introduction to some key terms in statistics. But first, let's talk about why you're taking this class. Why is statistics important? Statistics is basically the science of data. It deals with the collection, analysis, and presentation of data. So that's essentially what we're going to be discussing this entire semester. Appropriate ways of collecting, analyzing, and presenting data. When used correctly, statistics show us patterns in what happens in the past and can be useful in predicting what may happen in the future. And these are some examples. Climate change. The reason we know climate change exists is because of statistics, because of analyzing changes in temperature and looking at those numbers very closely. The relationship between fetal care and human development. It's common knowledge in science and in medicine that the relationship between these two is extremely important. We know that if a baby in the womb does not receive proper care, that could ultimately lead to birth defects or other problems in the development of that human being. Business performance. In order for a business to determine if it's growing or if it will experience a larger profit, it uses statistical calculations. These are the key words that we'll talk about in this video. Make sure that you know what these words mean and you know how to use them. So we're going to talk about what a variable is, data, quantitative, qualitative, discrete, and continuous. So when talking about what statistics is, I mentioned this term a lot, data. So what is data? To understand what data is, you first have to understand what a variable is. A variable is a characteristic of interest for a person or thing. Examples are height, eye color, or salary. These are all considered variables. Variable sounds like varies, because these characteristics vary between each person or thing. For example, a height can vary from person to person, an eye color can also vary, and a salary can vary from one person to the next. Data are the actual values of the variable. They may be numbers or they may be words. For example, if you look at the table at the top, the top row is showing the variables. So race, income, height, years of education, those are all variables. And then under these titles are the data. So here's some other examples of the difference between variable and data. If I wanted to know the average height of boys in a city, the variable is going to be height. But the data might look like this. It'll literally be the different heights that I collect of all the boys in that city, such as 5'11", 6'3", 5'9". Those are all data values. Here's another example. Let's say I wanted to know the percent of people in a school with brown eyes. The variable is going to be eye color, because that's the specific characteristic of interest. But the data, again, is going to be the values that I collect. So if I'm trying to gather information on eye color, then the data values are going to be different eye colors, such as brown, black, blue, brown, black, etc. So now that we understand what data and variable mean, let's look at the difference between quantitative and qualitative, because a variable can be one of these two. Quantitative variables are the result of counting or measuring. They are always numbers. The word sounds like quantity. Examples of quantitative variables are weight, time in minutes, GPA, age, shoe size. So all of these are expressed using numbers. Your GPA might be 3.2. Your age might be 18. Your shoe size might be 6.5. Qualitative variables place the person or thing into a category, and they are expressed using words. Examples are political party, eye color, gender, ethnicity, etc. Your gender could be male or female. Your political party might be independent, Republican, Democrat. So all of these variables are expressed using words, not numbers. Now that we know the difference between quantitative and qualitative, let's look at the difference between discrete and continuous. One important thing to remember is these terms specifically apply to quantitative data. Quantitative data may be either discrete or continuous. Discrete data involves counting numbers. So literally numbers that you can count on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. An example is counting the number of phone calls you receive every day. You might get values such as 0 calls, 1 call, 2 calls, 3 calls. You might get 10 calls in a day. But you can't get anything in between those counting numbers. For example, it's impossible to receive 1.5 calls in a day. It's impossible to receive 5.23 calls in a day. Continuous data is not only made up of counting numbers, it can also include fractions and decimals. An example is measuring the length of each phone call that you receive in a day. So if you're measuring the length of phone calls, you might get a value such as 2.4 minutes. One phone call might be 7.5 minutes. Another one might be 11 minutes. Another one might be 1.233 minutes. So to summarize, just keep this in mind. Data can be categorized into either qualitative or quantitative. And then we can categorize quantitative even further by separating it into discrete or continuous.